Hello, this is Olajide from CTF Security and welcome to another practical video on SQL injection. Today, we're focusing on an advanced SQL injection technique, specifically Boolean-based blind SQL injection. Unlike traditional SQL injection, where you can directly see the result of your injected queries, Boolean-based blind SQL injection relies on true or false responses to infer information from the database based on how the application behaves. We'll start by dictating a vulnerable endpoint, then move on to extracting data from the database. We'll also attempt to execute some Linux command through our injection to read files on the server, thereby demonstrating just how far you can push this technique. So without further ado, let's get started. Okay, so welcome back to today's exercise. The lab we're going to be using for today's demonstration is called Photo Gallery, and you can find this on Hacker101 CTF. All you have to do is just to create an account, and then you can access the ctf.hacker101.com/ctf, and this is going to take you to the list of all these CTFs right here. So what we're going to do right now is to hit the start button, and then this is going to take few seconds to spawn up our lab. So while that is coming up, let's go ahead to set up our documentation for this particular exercise. So what we need to do is let's use this one. I already have a directory for Hacker101. So what we need to do is to make directory, and let's call this, I think the name is image gallery or so. So let's go back, make directly image or photo gallery, cd photo gallery, and then we can create a text file called photo gallery.txt. All right, cool. So the first thing we want to do is to have our domain. So we're going to call it target domain, and let's grab our URL in there, and we're going to put it right here. So what we're going to use this document for is just to document our findings and probably to modify our payload that we're going to be injecting into the web application. So having done that, let's head back to our application, and you can see that this happens to be a gallery web application, and we have some random pictures of some cards. We have a title, magic image gallery. We have utterly adorable, we have perfect, and we have invisible, and then we have the space use equals to 0 total. Now, the first thing I like to do is to right click and view source code. Probably we might get a hint of what we expected to do right here. Now, if you look at it critically, let's text wrap this. We have our HTML document with some tags in it. We have the header 2, which has the kittens in it. We also have the div tag, where we have some images appended to it. That is exactly what we are looking at right here. So we have an endpoint here with a parameter ID. So we have the fetch endpoint with a parameter ID 1. We also have another one, ID 2. So I'm guessing this is for ID 1, this is for ID 2, and this is for ID 3. What else do we have? Do we have any other thing? Okay, so we also have space use equals to 0 total, which is exactly what we have here. Okay, so there's not much information, there's no flag in here. So we have to do the job in order to get our flag. Now, first thing I would like to do here is to make sure that I have my BurpSuite listening. So you don't necessarily need to turn on the intercept, and I'm currently using the BurpSuite Professional, so you can also do this with the BurpSuite Community Edition as well. So the first thing we want to do is make sure that I'm intercepting the request. So we have our Foxy proxy set to Bob, which is perfect. So what we are going to do is to just reload the page one more time and head to the Bob suite. And you can see that this has been captured by Bob suite. If you take a look at the URL, we have the 8764, and you have exactly the same thing right here. So what I'm going to do is to add this to my scope. And then from the proxy tab, we can head to the HTTP history and we can filter our scope, and then we can apply. So now we will not get any responses or requests from out of scope item inside the HTTP history. Now you can see these are the endpoints that are being loaded by the application. We have the ID equals to 1, ID equals to 3, and ID is equals to 2. So the first thing I would like to do is to right click on this and let's send this to repeater. Okay, so let's send it and see what we get. So you can see that we receive a 200 OK response, which is nice. And I think this happens to be an encrypted form of the image, if I'm correct about that. So let's see what happens if you make this to be 2. Okay, so we receive another 200 response, but this time around we have I think 98,716 content length. And when this is 1, what happens? Okay, we have a different content length. What if it's 3? We have something different. You can see that we have 500 internal server error. So I guess that is the reason why we're not able to view this invisible picture. So possibly our flag might be lying within this particular invisible picture here. We don't know yet. So let's head back to BurpSuite. Now, since we see that we can actually manipulate this ID, the first thing I'll try to do is to force this endpoint. And in order to do that, we can just right click and send this to intruder. And from the intruder, we're going to clear the screen. And then I'm just going to select the ID here. And we're going to add this to the intruder. We're going to use sniper, then move to the payload. Let's see what we can use. I think we have numbers. So I can use from 1 to 100, and let's see what we get. 1 to 100. So we want to actually force the ID between the range of 1 to 100, and we want to use a step of 1. So we just have an interval of 1, 2, 3, 4 continuously till the 100 value. All right, having done that, I think we are good to go with our forcing. Okay, let's go back to the position and let's start our forcing. Okay, great. You can see that we have slightly different response here. We have the first one, which is for ID 0, which is 438 content length. And for the response, we have the 500 internal server error. Then for ID 1, 2, which is the image that is being displayed on the screen, we have the content length of this and this. Then for others, we have 500 for ID 3 also. And for ID 4, we have 368, which is 404 not found. That means we're not able to see any information regarding that particular ID. which is interesting. So you can just sort through the data and you see that the only valid ID that we have here is the ID1, ID2. For the ID3, we're getting a server error. All right, cool. So the next thing I want to try here is I'm just going to close this. This is a no-go area. So let's just close the intruder and then let's head back to the repeaters tab. Now from here, we want to test if this application is actually vulnerable to an SQL injection. And the first thing I like to try is to append a single quote, and then we're going to send this. And you see that we get an internal server error. Okay. So what if I change this to a valid ID? We also get an internal server error. Okay. So what if we have a Boolean based blind SQL injection? Now, just like I described in the introductory part of this video, in a Boolean based SQL blind injection, the attacker send SQL query to the database, which force the application to return a different result depending on whether the query returns a true or false result. Depending on this result, the content of the HTTP response will change or remain the same. This allows an attacker to know if the result is true or false, even though no data from the database is returned. Now, what we can do in order to check if this is actually vulnerable to the Boolean based blind SQL injection is to use, let's say, a valid ID, which is 1, and then we can use a logical operator, and then we can pass a condition that always evaluates to true, which is 1 equals to 1, which will always be true. And then we can just highlight this and URL code. You can right click, convert URL, encode key characters, and then I can send this and see what we get. So you can see that we actually get 200 okay with a content length of the first ID. Okay, so what if I change this to 4, an ID that does not exist? You see that we got 404 not found out. So what this is practically telling us is for this particular query to be executed, which is the 4, let me just change this to 1. For this query to be executed, let's highlight that. Both the first query and the other part of the query needs to be true for this particular query to be executed, because that is how the AND operator works in an SQL command. Now that we've seen that this is probably vulnerable to an SQL injection, let's see how we can actually leverage this. Now, what will possibly happen if I change this? Let's just decode this back to the original form. Convert this to back to the original form. Now, what if I use 1 equals to 2, which is false? So we have ID equals to 1, which is a valid ID, and 1 equals to 2, which is false. So we expected to get an error. So let me just URL encode this, and I'm going to send it over. And you can see that we have 404 not found. Now, if we change the 2 to 1, we're expected to get a 200 OK response from the server. So you can see it right here. So now the next thing we want to do is to see how we can actually leverage this. Now, before we actually do that, another way you can actually test for this particular SQL injection is to use the BurpSuite professional scan. And a simple way to do that is actually go to the proxy tab where we have our requests. You can just right click on that, then you can scan, I'm going to choose audit selected item, and then I'm just going to hit the OK. And what is going to happen here is the BurpSuite professional is going to perform a scan. You can actually see the scan going on here. And from here, we're able to manage and view the report of the query based on the severity. And I'm going to come back to this when the scan is done. So you don't necessarily need to start throwing up random commands into the application. Now, while that is running, let's head back to the repeater tab. Now, a very simple way we can leverage on this Boolean based SQL injection is to use a very popular SQL injection tool called the Ghauri. I don't know if I'm pronouncing that correctly. So what we're going to be doing right now is we're going to be attempting to use the Ghauri and the Sqlmap to dump data within this particular database at the same time simultaneously. This way we're able to actually compare the speed of both application as well and their effectiveness. Now, to do that, what we're going to do is to just spawn up two new tabs. So this is one. I'm going to open one more. Let's just make this a bit bigger. So we're going to start with the Ghauri. Okay, but before then, let's actually see manual testing. So we're able to establish that this might be vulnerable to Boolean based blind SQL injection. Now, sometimes we have the same application or endpoint might be vulnerable to both the Boolean based blind SQL injection and the time based blind SQL injection. Okay, so what else did we find? Okay, so now we're going to use the Ghauri, using Ghauri to dump database tables information. Okay, so to do that, let's head back to our terminal. So we're going to use the Ghauri. I'm going to drop the link for the installation for this particular application in case if you don't have it installed. So we're going to issue the user. So this is going to be the URL and the endpoint, not the user. I beg your pardon. So to grab that, we can just easily get that from our BurpSuite. So what I'm going to do is to go to the proxy, just pick up the request, and then we're going to copy URL. So let's head back to our command. I'm going to paste that in here. So we have our URL, including the endpoint and the ID parameters. So the next thing we're going to do is to set the parameter to ID. I can actually use double quotes. And then we're going to issue the dump command. This is to pull data from the database, and then we can set the thread so that we can have a faster execution to possibly 10. I don't think you can set this above 10. So let's run that and see what we get. Okay, so while that is running, I'll just copy the similar command and let's go to another tab, and here I'm just going to change the Ghauri to Sqlmap. Oh, okay, so the extraction process has started. This extraction process is going to take a while, so I'm going to put you on hold and speed up the video to save time. You will still see the key step, but it will be faster. So But before we get to that, let's see if our BurpSuite scan has successfully completed. So let's go to the dashboard, and you can see that our scan is still going on. We have a critical issue already. So what we need to do is to click on view details, and then you can see that we have issue one. We have different categories of issues depending on their color. So you can go to audit, and then from the audit you can actually see the request, and you can see the issues relating to that request. And here we have the issue found is SQL injection, and this happens to be on the fetch endpoint. Okay, so you can also see other information when you click on it. We have the first request that was sent, the kind of injection which it is, which is an SQL injection. The severity is high. The confidence level is firm. This is the part of the injection, and you can see some of the payload that was used. This is an example of something similar to what we used, but this happens to use the or logical operator. We also have additionally a time-based SQL injection. So you can actually see an SQL query asking the server to sleep for about 20 seconds, I guess, before it responds to another query. So that is exactly what this is actually doing. So we can see that this is vulnerable to two different kind of blind SQL injection: the Boolean-based blind SQL injection and the time-based blind SQL injection. And you can also see the request that was sent. So this is how it was tested. This is the first request. This is the response the application got back. So you can see the response contain the content length of the first image. You can see the second request that was made. This is the response that was gotten. So this is the payload that was sent for the time-based SQL injection testing, and then we can see that this is the response that was received from the server. So obviously what we can do is to just go away from this, since we have been able to establish the fact that our application is vulnerable to two different kind of SQL injection. So what we can do is to just add this to our documentation. So BurpSuite scan says we have one Boolean based blind SQL injection, and number two, we have time based blind SQL injection. Okay, so let's see how our scan is going on. So let's head to the Ghauri. So Ghauri is saying it looks like the backend database is MySQL, which is actually cool. Do you want to skip test payload specific for other DBMS? Yes, since we're able to establish that it's MySQL, so we want to actually skip testing for other database types. So we're going to put yes and click on the enter, and this will enable our extraction process to carry on. So let's check for the Sqlmap. So we have something similar. So I'm just going to reply with yes. And we have another question. For the remaining testing, it says, do you want to include all tests for MySQL level 1 risk value? So we're just going to reply with yes. And this will also proceed as well. So we could actually test for the other SQL injection we got here. Let me see. I think I have it on the dashboard. Let's go back to view details. Okay. So let's go to issues, SQL injection. I think it's on the request 3. So we could use something very similar to this. Let's see if this will actually delay the response time of the server. So let's go to let's see, move over from this one, go to repeater. Okay, we don't have anything on repeater because I closed it the other time. So let's just go send another one. Okay, so from the repeater we can actually put in this payload, and we can use the logical operator to bind this. So we can say one and make sure we URL encode the space. Okay, so let's see. Does this in any way delay the application for 30 seconds? Okay, so you can see. So you can still see that we do not get response on time. So approximately this is going to wait for 30 seconds, then we get a response. So you can see. Okay, so let's see the status of our Ghauri. Okay, so we have get parameter ID is vulnerable. Do you want to keep testing for others? No. So since that is vulnerable, we're just going to stick with that. So you can see that we got our payload, a different payload for term-based blind SQL injection and a different payload for the Boolean-based blind SQL injection. And the Ghauri have started retrieving information from the database. So let's see the other one. So considering lagging has been detected in the connection, I think this has to do with a network issue from my end. Do you want to retry to find proper union column with fuzzy testing? Let's go with yes. The length of the query has already been extracted, which is the name of the database, I guess. So that is actually being retrieved correctly. So while that is going on, let me just take this other payload and see how it reacts on the BurpSuite. So let's say one end. And let's do this for say 15 seconds. So you can see there's a delay in the response time, and this is expected to last for about 15 seconds before we get a response. Okay, so we got a 404 error as well. Okay, so I'll be coming back to this. Currently, let's go to Ghauri and see how these information are being extracted. So already we're able to extract the name of a database called level 5. This is actually the length of the name. We also do have number of table for the database, which is 2, and we've already retrieved one of the table, which is albums, which makes sense. So let's see what we'll get for the second table within the level 5 database. So while that is going on, let's also see we are here to get a hit from Sqlmap. So we're just going to wait for that as well. Okay, so you can see that we also have our second table, which is photos, which makes it two table within the level 5 database. So fetching columns for tables, photos. So what we're actually trying to do right now is to dump all the necessary columns that we have within the photos table, and that is going on right now. So let's see what we have. So we're here to get anything from Sqlmap. So let's play around a bit with the payload from the BurpSuite. So what happened if I remove the ID and just run the command to sleep for 15 seconds, and then let's see what we get. So we have a delay. Okay, cool. Okay, so what happened if I change this to 2 seconds? Let's see if that is faster. So you can see that we get our response on time. So that is actually telling us that this is vulnerable to the time-based SQL injection. So let's put this to 60 seconds. Then you see the delay. But this is actually going to take a while before we get this response in here. So still counting, still counting. So we definitely do have a delay. All right, cool. So we're here to have a delay. I beg your pardon. We're here to have our response because it's expected to wait for 1 minute, which is 60 seconds. Okay, we are here to have our response. Okay, cool. So we have our response, which is 504 gateway timeout. I guess we exceeded the number of time it's supposed to wait within the application. So let's go back to Ghauri. Okay, so Ghauri has been able to extract another information from the photos table, and that happens to be I think this number. We have ID, we have title. So we expect to have two more columns within the photos table. Okay, so we have get ID parameter is vulnerable. Do you want to keep testing the others, if any? No. So we're going to reply with no. And again, we see that we definitely do have a payload. This time around, a more different payload than the existing one we used. So you can also see that dumping of the database has already started, which we are fetching current database. We're also retrieving the length of query output already, just like the way we did with the Ghauri application. Uh, okay, so we have our third column from the database, which is file name. So let's see what the fourth column is going to be. Let's see, can we actually put this side by side? Will that actually look nice? All right, cool. So this is Sqlmap and this is Ghauri. Okay, so we have all the four columns documented. So while that is running, I can actually grab this one. So let's copy this and let's put it in here. So database extracted. The name is level 5. That's the name of the database. What other information do we have? We learned that we do have two tables within the database. Tables as two tables, photos and album. We also have inside the photo table, we do have table columns. So we do have ID, we do have title, and we do have file name and parent. I absolutely do not have any idea of what that is, the parent, but we get to see what that will be. So I think that's the information we have so far. Uh, okay. Okay, so what next are we doing? Fetching entries of the column ID. So actually what we're doing now is we're extracting information within each of these column. That is the ID column, the title column, file name, and the parent column. That is exactly what we are retrieving right now on the Ghauri. On the Sqlmap, we are still extracting the photos table and the ID. So we are currently extracting the table columns. Okay, that is exactly what we're doing. Fetching number of entries for table albums. So the information that is being fetched right now is for the album table here. So right here we are fetching information from the photos column. Okay. Okay, so I guess we are having network issues. Um, we already are trying to retrieve the information again. I guess that is going to cause a bit issue, which is already happening on the Sqlmap. But I think we're back with the Ghauri application. So let's see what we have been able to extract. So here we did extract some other columns. This is still on the level 5 database. So 3 was received. The first one that was retrieved was the, I think, utterly adorable. So I guess that should be image of this one. So possibly we are extracting this one right now, and then lastly we're going to extract the invisible. So let's go back and see. So but we have issues here, so maybe one of the database data might be missing because of the network issue. but we might actually capture it using the Sqlmap or during the Sqlmap execution. So we are done extracting the file path for the first image, which is file slash adorable.jpg. Okay, let's see what the second one would be. So I don't know if I mentioned this previously, but this is actually information from the album table, and we have just two columns. We have the ID and the title, and the information within it is just one ID and kittens. This is just the information we have inside the album table. So most of the information is residing inside the photos table. Okay, and this is the photos table being extracted here. And I think we are doing the same thing on the Sqlmap as well. Okay, yeah. So we started extracting photos table. So this is the exact same thing that was extracted here, and the Sqlmap is actually extracting it too. Okay, so we have the second image, I guess. So this one was the first one. This is the second one. Perfect. And this is the one we're actually extracting now. Okay, so this is expected to also extract the perfect file. So for the file name, I think we have 18 character length. So it's going to be something similar to this. File slash the name.jpg. Oh, this is saying 16. Okay, let's see what the output is going to be. Oh, okay. That's the same thing that's been extracted before. Which is the author adorable. Okay, which is this one. So the order is just actually different. I think that's what we have. The order in which the information are being extracted. So now this has a length of 18, and that would be the perfect file name, I guess. Okay, so we are close to extracting the invisible picture here. So we're going to see what is beneath the database in this particular image right here. Okay, I think we've started the extraction of the invisible file. Yeah, I think so. So what is the length of the query? What is the length of the query? So the length of the name should be 8. Then the actual file should be more than that. Oh, this is still perfect. So the SQL map is still extracting the perfect file. Okay. Let's see what Ghauri is doing. We have 64 length for this particular extraction. I guess that will be the invisible picture. Yeah, so we have 64. Okay, so since that has started, I think what I'm going to do is to make this bigger. So we're actually dealing with the SQL map right now. So the SQL map is already extracting the invisible file image, or the invisible image file. So I guess this is going to be our flag or something. But we're expected to find, I think, 3 flags. We're expected to find 3 flags on this. I don't know why I closed this. So can I just open it in a new tab? CTF dot hacker101. So let's just open that so we know how many flags we're submitting. So we're expected to submit 3 flags. So this flag has already been submitted, but I'm still going to submit them anyway, just to show you how you expected to submit your flags. Okay, extraction process is going on here as well. Still going on here. So let's see what Ghauri has for us. So it hasn't really started. Okay, so we just have the extraction going on. Okay, let's see Sqlmap. We have 55 character already extracted, 57, 58, 59, 62, and 98. Okay, so I'm just going to grab this one, and it looks like a flag. So we're just going to possible, let's call it possible flag 1. Just put it in here, and let's go back and see what Ghauri is doing. You can see Ghauri is also extracting the same thing. 98 ADF. Is that exactly what we have? You can see it. 98 ADF. Okay. So what are we extracting? What are we extracting next? This should be the file name, I guess. So we expected to have let's go back. We expected to have the ID, the title, the file name, and the parent. So I guess this long string is inside the file name, and probably we're extracting the title right now on the Sqlmap. So this is the Sqlmap. Let's check out Ghauri. Still on it. Sqlmap. Yeah, so this is the title right now that we're extracting, which is invisible. So do you want to store hashes to a temporary file? So this is actually treating it as um, hash. It's actually treating this value as hash. So it's asking, do you want to store hashes to a temporary file to eventually further process with other tools? So possibly if you want to actually subject this hash to another password cracking tools like John the Reapers, Hydra, or whatever, or Hashcat, I beg your pardon, or any other password cracking tool. So for now, we're just going to say no. Do you want to crack them via dictionary attack? No, we don't want to do that. So we have a summary of our photos table. So you can see we have the ID 123, we have utterly adorable as the title, perfect, and we have invisible, and we have the file path for the first ID, the file path for the second ID, and then we have this to be our file path for the third ID. Okay, so let's see what else we can do or what Ghauri is currently doing. Okay, so Ghauri is still extracting the same information. Okay, so the next thing is we have the first flag. One thing we could also do is to get other information on how we can actually proceed on this application. And there's one of the int I think that was given for this particular photo gallery. So if you go to hint, let's see, the first int for flag 0, it just says consider how you might build this system yourself. What will the query for fetch look like? Let's get the int for the other one. Okay, it says you don't really have a hint. Okay, take a few minutes to consider the state of the union. Oh, this is still another int under the flag 0, which we found already. Let's just confirm that. I'm just going to copy this and let's head to submit flag, and let's just paste this in here and check. Say this is a valid flag and it has been claimed before. Okay, so our Ghauri has successfully extracted the invisible file name as well. Now, there's one information that was not actually given to us in this particular lab. That is, what kind of technology stack this particular application is using. And this led me to a lot of rabbit holes in such a way that I had to try to read different files for different kind of programming language. So, but what I actually did is you can actually move to the BurpSuite application. Let's just reload the page, and let's go back to the BurpSuite, and let's just pick the request and send it to repeater. All right, cool. So what you can actually do is to use the same payload, which is and union, or you can just say, instead of that, one space union. Then you can select everything. So let's see what this is going to give us. So I'm going to URL encode this, Control U, and I'm going to send it. So we got internal server error. Okay, so what happened if this is in a code? One union select this. Okay, cool. So we're able to use a valid ID along with the union command to select all item on the database. So what happens if this get changed to a non-existing ID? What do we get? We get a 500 error. Okay. So actually what I did um, was to actually see if we can read index.html. No. Index dot, let's just put this in quote, index.html, send this, uh, nothing, index.php, do we have something? Nothing. Let's see if the flags application, main.py, and we get a hit. So you can see that by combining a non-existing ID using the union, which is going to combine this particular query with the existing backend query for the database, is just going to try to concatenate both query together and display the result. In this case, you can see that we have a hit, and I can actually just copy or show response in browser, and let's go to a new tab. Let's just paste this here and just load. So you can see this is what we have been able to extract from the application. So this is the main.py. This is the main.py. So we have title, album, we have an image, we have some query in here. We can also see that we have some of the database credential exposed. For example, we have the host as localhost. We also have user equals to root and the password is set to empty. We also have some sub process check output. But first of all, let's grab, I think I saw a flag. This is another potential flag. I'm just going to copy this and let's add it up to this. So we have another potential flag. So let's head back. Now, if we take a look at this code right here, you can see that, let's start from the first query. So this is cur.execute, select ID, title, file name from, where parent equals to this, limit ID. Okay, so this is actually not for the slash fetch endpoint, so I'm actually looking for slash fetch endpoint. Okay, so this is the first part of it here. So we have if cur.execute select, so this is the underlying query that we have. I'm just going to select everything here and let's just put it here. So we have backend query. Not forgetting, we also found out there is main.py, which signifies a Python application. Okay. We also have backend. This is the query. Do we have something else? We have a sub process which is executing this usage and is using the tag C and the tag H, and this is piping it into exit 0. Okay, so let's just grab this particular part of this query. Just grab this. This looks interesting as well. Now, if you look at these two commands, now the issues that we have here is on this main.py, the first thing we want to take a look at is this backend query. And this is the reason why the application is vulnerable to SQL injection in the first place. So you can see that the application is using string interpolation here, which is this percentage sign here. Now, when you use string interpolation to construct a query, what you're actually doing is you are risking injecting untrusted user input directly into your query. If this input isn't sanitized properly, it can include characters that the query will interpret as command, leading to a particular injection. In this case, SQL injection. We also have something similar on the sub process here. So we are also running du, we are running -ch, and we are piping this into, this is logical OR. So we're piping it into exit 0, and we're still using the same string interpolation to execute the file using the join file slash then the file name blah 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 blah. Now, one of another issues that we have here is we are setting the shell to be equals to true. Now, this particular sub process .check output call is vulnerable to shell injection if this particular fns, which is the file name, contain users control data that isn't sanitized. In such scenario, an attacker could inject malicious command through the file name. So basically here, by merely looking at this particular main.py file that we have here, we can actually spot 2 or 3 known vulnerabilities within the application. The first one, which is one of the most delicate one, is the SQL injection in the backend query, and that is exactly what we have here, because we are using string interpolation to append user input into our query. Secondly, we are setting a shell equals to true. Now, when you set shell equals to true in a sub process, this means that the command is executed through the shell. Now, this allows shell features such as command substitution, command piping, command chaining to be used, which introduces risk as well. So now we're able to run some shell commands within the application. That is an attacker based shell command within the application, and I'm going to show you how this will actually work. What we are going to be doing here is, let's go back to our extracted data. Okay, I think one of the file is missing here in the Ghauri, so let's use the Sqlmap. Okay, so we have an ID1, ID2, and ID3. Now, what we can do is to try to update this particular record that we have here, which is the file name, to our own control command. Now, if we're able to do this and we're able to commit this change within the database, this will cause the application to execute that particular command and redirect the output into a particular location on the server, and we're able to read this file. Now, I know this sound very confusing, but let's just get to it. Now, to do that, what we're going to do is, let's just get our command, which is exactly the same thing we have been using here. So instead of viewing the main.py, what I'm going to do is use a valid ID, and we're going to update photos. Remember, the name of the database is, the database table is photos. We're going to update photos, and we're going to set the file name, which is one of the column we want to update, equals to. Now we can actually just set this to anything, just like we did before using a wildcard. and we can pipe this because the shell command injection allows piping and command chaining. So we can as well run a command. So in this case, what we're going to be running is just, let's just run ls-pals, which is just going to list all the files and directory within the current working directory. And it's also going to redirect. So let's redirect the output into a file called temp.txt. Let's just call that temp.txt. And let's close this. Do we open? Yeah. So we're going to close this, and we're going to specify the where clause, which is where id. Where do we want to actually insert it? Inside the id equals to 3, which actually means that we're inserting it inside this place where the id, which is the primary key, is equals to 3. Okay. So what else do we want to do? Then we want to commit our changes so that this can get executed. And then we want to, sorry about that, id equals to 3. We end this and we can commit. Okay, so I think everything looks okay. We want to update where id equals to 3, and we want to commit, and we end our query. All right, cool. Let's see, can we url encode that? Control U, and let's send us to see what we get. Okay, so we get 200. Okay. So what we need to do is come to the home page, refresh what we have. So you can see that we're having 0 as the space use size here, but now we're having 196. This is because what we have done is, let's go back. So what we have done is we've actually listed the current working directory information within the server, and we've directed the output into the temp.txt. Now, what actually happened is that the du, where's it? Where's the sub process? Okay, so the sub process ran the du-ch against that particular file name, which now is going to be the temp.txt, and it got the size to be 196. So this is exactly the same way of saying, for example, let's say cd document. Do I have any valid documents I can use? Okay, yeah, ls. So let's see. So for example, I can run du, that is disk usage, use the ch command, and then specify the file, which is this particular file name. And you see that this gets this output the file size, that is the total file size for this particular file .txt or file document that we have in here. So that is exactly what is happening within the application. So you can see it. So if we actually update this again, we're going to get something different. Now, if we go to the BurpSuite, we can now modify. If you want to actually see what has been executed, we can say this time around, let's just use 4 or 9, just any value. Space union select, then the name of the file we just saved, which is temp.txt. I hope I spelled that correctly. So I'm just going to highlight, Control U to URL encode. We're going to send this. So you can see that we have been able to list all the files within the current working directory within the server. Now I can actually right click, copy, no, right click, Or what have I done? Let me just run that again. Okay, right click, show in browser. You can copy this, just open up a new tab, and we can have this here. So you can see that everything is being listed, including the sizes of the file. So we can actually use this to see if we can view the shadow file, or we can actually view the st/password, the same command. So we're going to run the same command to view the st/password. Let's bring back the last command we ran. I think that should be here. Go back one step. So this time around, instead of running lspals, you can just say you want to run, let's say, cat plus for the space, um slash etc slash password, and let's put this in temp1.txt, and let's run this. Okay, good, we get 200. Okay, so let's refresh. So we can actually confirm. Let's reload here. We have something similar. I don't know if that has executed, but let's just confirm. Let's go to Bob. Uh, here, let's just add one and send. So you can see that that's successfully executed, and you can see the sc/password file. Now, how do we get the last flags for this particular challenge? Now, what I'm guessing is some of the information or regarding the configuration of this installation will be saved within the environment file, which is the env file. So what we're going to do is to try to read the env file. So let's see if we can actually modify that. So here, instead of viewing file, let's run the env, and we're going to put this in temp2, and then let's send us. Yeah, I think everything is okay. Okay, so let's just refresh, and then let's go back to BurpSuite. Let's go to this request here, and we're just going to change the 1 to 2, and we're going to send. So you can see that we've been able to view the environment files for this particular application. So what I'm going to do is to show requests here, and let's head to our browser and just open a new tab. I'm just going to paste this in here, and we'll be able to see informations that we have here. So we have some flag here. This is one, this is another flag. Okay, this is another one. I'll just copy the entire flag. We have our GPG key as well. But first, let's go paste this one. Other flags. So let's remove the code. This is one. This is another one. Remove this. Remove this as well. So we have our third flag. So this is the one we found on the file name in the database. This is the one we found, I think, when we're able to read the main.py, and this should be the last one. So you can as well submit all the three flags. So let's see. I think I've submitted this one before. This is the first one we got. Let's just arrange them. Copy and just put it in here. Okay. So we have all the three flags within the environment file. Let's submit the other two. I'm going to copy this, head back to submitting the flag. And this is going to tell us that we've already submitted this. So the flag is valid and it has been claimed before. So you can see it. We also got the flag is valid and it has been claimed before. Aside from using command chaining, just for learning purpose, we could also use, I think, command substitution in order to execute command on the server, which is very similar to what we did here. So for example, we might want to actually do something different, like here, just within this part here, before the where. So we can have update every information file name equals to which is this one, asterisk, the pipe symbol. Then from here we can have something like, I think, the dollar sign. Then we can put our command within a bracket. So for example, you can run who am I and possibly redirect the output into temp 3. I think we've done temp 1, temp 2, temp 3 dot txt. I think that's all. And let's run this to see. Okay, so as usual, we're going to refresh the application. Then we're going to check if that's actually executed successfully. 3. So you can see that we are currently root, which is a root account. That is the account that is above other accounts within the application. So I guess there's no further thing we need to do on this particular machine. I couldn't find any reasonable user when we extracted sc/password file, but you can as well, just for learning sake, um let's see, for second one, you can as well just cut, let's say, space /etc/shadow. Did I spell that correctly? Finally confirm that. Cut /etc/shadow. Sudo sudo okay, shadow. Or I think we should be able to do that as well. S/shadow file, and let's put it into 4 and send. Response was okay. We're going to refresh, and then let's go to the third one, and we're going to, no, that's wrong. We're going to view the fourth one, temp 4. We're going to send. Okay, so you can see there's no reasonable password. Everything is just the service account and stuff like that. Okay, guys, that will be all for today. Thanks for watching. If you find this video helpful, please like, share, and subscribe for more content on SQL injection and other cybersecurity related topics. See you in the next video.